Okay, this is a very quick overview of the product that's in the labs at the moment. The product's called Project Vasari, and it's a subset of Revit architecture. So the functionality may well end up inside Revit architecture or may be a separate product. There is no decision about that yet. I just wanted to let you see what it is that it does. So if I open it up, the first thing that you're going to notice is that the interface is very much simpler than Revit because it only deals with the creation of conceptual models, really the outside surfaces of a building, which is then going to let me analyze. So if I, just about there, the interface, like I said, looks a bit different. You notice that up here I'm actually already in the mode of creating a mass model. I'm going to turn off the movies. I don't need to look at those just now, but with the product you'll get an explanation by way of 8 movies on how the product works. So just to point it out to you how it works, is the sequence I want to show you is I'm going to model the mass, I'm going to assign settings to it in terms of where is it in the world, what kind of building is it, what's its orientation, apply those values to it, then analyze it, get some feedback in terms of how much electricity does it use in a year, what's its potential for using photovoltaic cells, those kind of things. So it's a very quick process. If I just go through it, I'll show you the steps. If I draw this building, so you see I can control the size of my model. I can pick on that shape that I drew, and I can say now go and create me a solid form, so that would be like the height of my building. What's very different about Vasari and the concept modelling, is you can see that this is very editable, kind of like SketchUp. What's a little different from Revit in this is that I can do things like I can see my levels in 3D, so I could say, well, the height of my building is to be aligned with this level at the top of my building. In Vasari, these levels represent really floors that will cut through the model. So once I've made my mass model, I'm going to do this very quickly. Once I've made the mass model, my next step is to select that mass. You see that I can edit it very easily by just tugging on the handles to change the shape. But I say apply the mass floor, so I can tell it that these levels, that's what you're seeing here, are to cut through the model, and you can see immediately that it's got the floor planes that cut through that. Great thing about this is you see how quickly it gave me all the data on what the external wall surface area is and what the floor area is, and this is a fairly easy, straightforward shape, but the point is I get that data very quickly, something you don't get from SketchUp or anything like that. When I've got this model, now I can go up and I can do the analysis. So I can say where's my location in the world. It takes me really to Google Maps, but it uses data that's on Autodesk servers that are based in Boston, Massachusetts, which is why the default project address is Boston, Massachusetts. But if I were to come in here and say Madison, oops, type to save my life. Oh, I know what's going on. It's because I've got another product running in the background here. Let me just do it like this. I rely on the Google to sort out what I mean. So you see I can actually see where Madison is, and I can, in here I can zoom in on the location. So that is my actual project, and I can locate it wherever I want in the world. And the neat thing about this is that there's a huge database of weather files in the location that it'll use to help me analyze the model. The next thing I do is go to the energy settings, and I can tell it what kind of a building it is. Let's say it is an office building. I can tell it to create the energy model, and I'm going to just turn off by setting to 0. I don't want an interior zone central to my building. If I did, I could tell it what distance that is from the outside. I can set a percentage glazing. Let's say I just change the value to 56%. The target sill height, say of 3 feet. And if I want, I can even say things like when the glazing is shaded with a shade overhang of like 2 feet. For skylights, maybe I'm anticipating having like 5% of the roof skylights. I can look at the heating system and choose from the options here, and when I'm done, all I'm going to do is click OK, and there's my actual model. So now I can look at the model and I can say, well, show me just the mass form, which is what we saw before, show me the surfaces, or show me zones. And this is important later on in applying overrides, because at the moment all I've got is a model that's the same on all sides. But I may well want to do something like, say, show me surfaces, and then I'm on the north side of the building here. You see that I can actually go in and with the tab key here, I could choose to select that wall that's on the back of the building, and instead of using the values that came from the energy settings, let's see if I can make this a little bit bigger, I could go in and say, well, no, I actually want this face of the model to be something different. Maybe I only want on the north side of the building, I'm only anticipating having 5% glazing, and I don't think I'm going to need my shading, so do that and change the model. Well, I can do this for all sides of my building. I'll just go back to my 3D view here. So the other part of this is that now I've done the analysis here, or I've actually made the settings and applied it to my building, I can now say analyze the model. So what it'll do is it goes out and it finds the closest weather map that has, you know, like accumulated data over 25 years. And I'm going to log in here to the site. If you didn't have access to this, you would create your own access. I should have saved my drawing. I should have saved the model. But let me say I just call this study baseline. I'll say continue. What it does, it doesn't even run on my computer. It's actually running on the service, the servers in Waltham. And if I want to see the study that it's creating, I can actually go up here and say click on this and allow the content, and you'll see there's my study that I just created. I've got some, I'm doing a refit of my apartment, which is what this is. So, but down here I'm doing the energy analysis of this project that I'm working on. So you can see it'll also give me I'm going to close that at the moment, because I want you to see that you could continue working in this, and when it's finished doing the mass, so I could do something like say, okay, I'm thinking what difference would it make if I wanted to go in and change. Oh, it's finished already, it's not going to give me time. So now I can go back up and I can look at my model. But here's some of the data, right? It's got this, there's the closest weather station, maximum and minimum temperatures in Madison, 90 degrees Fahrenheit and -12. There's the floor area of my building, exterior wall. If it's an office, I can have occupancy with 228 people in it. And there's the cost of electricity in Madison. Say over 30 years, this means that building would cost me $1,177,300. Oh, sorry, $1,177,345. There's some potential identified here for what in the roof areas would, how I could use those roof areas for generating energy. I can get a carbon emissions study here to tell me what fuel consumption and the net CO2 in a summary here. It will show me, say for example, the distribution of the fuel used for the HVAC system and domestic hot water and the percentages of each. It'll show me the performance and the heating loads for the building, monthly cooling loads, fuel consumption, peak demand, sorry, it's electrical consumption, fuel consumption. It'll show me the direction of prevailing winds in the area for my site, even month by month. All this data that you can choose to analyze. So in a matter of a few minutes, I'm getting feedback on what the options for my building are. So I could come back here now and say, well, you know what, I've looked at the program, I've decided I can reduce the size of the building. Maybe I even want to edit it in place and say that I'm thinking about changing the shape of the building, so I'm going to delete this, and maybe on the south side of my building I'm thinking that maybe I'm going to do something more like oops, that, hold on, cancel. What did I just do? Oh, it's not closed. It's the rule is the shape has to be closed. I'll just leave that in so you can see the kind of how easy it is for me to correct this when I know what the rules are. So there's my outline. I say I'm finished with that. You can see now that I've actually adjusted the form of the building. So if I finish the mass form here, my building now looks a little bit different. You know, I've got a more interesting form on the front. My floor schedules have updated to show me the values in here. I can go back to my analysis thing now and say, let's. I'll just go up here to show you that you actually have a choice. I didn't show you this before, but there might be many different weather maps. It happened to choose the one that was closest, but there may be situations where you know, your site has some a pretty specific microclimate, and maybe there's a different weather map that's more typical of the microclimate for your site. So if I come back here, I'm just looking on this in my model, and I can say, well, let's analyze that one, right? Because I did the first one before, and I called it baseline. Let's call this one baseline 2. Oops, well. Continue. So it's going to go and analyze that. While it's analyzing it, let me do another kind of study on here, which is just looking, say, at the mass forms. I'm thinking that it'd be interesting for me to know what kind of performance I get, or what distribution of energy I get on the different parts of my building. So in my view here, I can come up and say, well, you know, I'm actually interested in, say, doing a multi-day study over the duration of 1 year, where from sunrise to sunset, I want to take all the data for 1 hour increments for the entire year and apply that in the study of the building. Let's say I want to see the results as kilowatt hours per square meter, as my other model is finished, and I'm going to say select the mass that I want to study here, and click to finish. And now what I've got is an analysis of my building that, if you like, is showing. So the reason I curved this is to show you how it's telling me that on the areas that collect most energy, I've got 850 kilowatt hours per square meter. And so if I had, like, I was thinking of putting like solar panels on this curved surface, I can tell, you know, where the best locations are. Obviously here the roof's a good choice. If I go back to my results and compare, I've now got my 2 studies on the energy analysis, and I can come up here and say compare them. So if I just, the changes that I made, you know, to my building, just in terms of the, say, the energy budget, you know, what was over $1 million is now $996,745. So the whole point is that as a designer, I can be making comparisons based on quantitative data between one proposed solution and another. And that's kind of where Project Vasari is at the moment. There's more to it that I can show you, but it's a good kind of summary of how I can control the look of the building and get meaningful results back for analysis.